Oak is a plugin suite consisting of 4 plugins. The first one is called Oak One, dedicated to stereo processing. The second is an OTT with low latency and low CPU usage, ideal even for tracking situations. Then the same OTT but featuring high quality options for crossover filters and oversampling. In this case, oversampling is linear phase based on FIR filters. Lastly, a processor that merges the concept of Oak One, expanded to a multiband approach with the OTT concept, which itself is multiband. It allows you to process each band individually, widening or controlling the stereo field, and applying a form of compression. The first plugin handles stereo processing. Its external controls include an elliptical filter that reduces stereo width at the extremes of the spectrum. Simply put, it filters the side component of the signal. Next, there are 3 stereo manipulation algorithms. The first is a kind of chorus. We call it super stereo, derived from our synthesizers. Its intensity corresponds to the age parameter in our synthesizers. The stereo effect is created by a Doppler-like pitch movement applied separately to each channel. There are 2 main families of algorithms: delay and resampling. You can choose the one you prefer. There are various oversampling modes available for enhanced quality. In this case, resampling is available at 2x and 4x oversampling. For single-band signals, we advise against setting the drift value too high, as it can introduce unwanted phasing and degrade signal clarity. Even a small amount is enough to emphasize stereo information, which can be further processed by the rest of the plugin. If you start with a mono source, even a minimal amount of the first control will give you an excellent starting point. The Orbit processor contains several algorithms that manipulate the mid-side signal, with a list of selectable options. Generally, these algorithms don't interfere with transient placement or timing. Unlike the first algorithm. Finally, there's an innovative processor based on algorithms derived from binaural processors. Similar to those found in Atmos or other multi-channel systems. The various algorithms correspond to different speaker placements and algorithm types. Here too, we recommend avoiding extreme values as you might perceive some delays. Nonetheless, the combination of these elements can deliver a balanced, coherent signal. OTT Live is an OTT plugin, short for over the top. A multi-band processor using upward and downward compression, meaning both expansion and classic compression. This creates an effect widely used in modern productions. Its main advantage is simplicity, as it features automatic input compensation. Let's see it in detail. You can link channels, meaning the 3 bands, and control them simultaneously using the depth parameter. As you can hear, no further adjustments are necessary. The signal is already balanced. If the sound feels too compressed, you can use the time parameter, making the sound less compressed or more extreme. As you can see, the gain is automatically adjusted, and the sound, even heavily squashed, remains well balanced, as if a single, well-set compressor were processing the whole signal instead of a multi-band approach. There are even more extreme modes, like Inferno and Wide Mode, range mode, providing maximum expansion. This is the most extreme version of the plugin. You can use trim to define whether the bands perform expansion, as in this example, or compression, or both simultaneously. If the threshold is set to minimum, the processor starts working as a classic compressor. These processors become interesting when expansion and compression act simultaneously. They can sound more natural, even on a master bus. Simply use much higher attack and release times, and certainly reduce the processing amount. Once again, the signal is compressed, but balanced. In this scenario, depth corresponds to a global dry-wet control. Actually, depth acts in conjunction with other depth controls as a global modulation for the three individual depth parameters. Bands can be adjusted independently. Without changing anything, the plugin still works perfectly. The bands are balanced automatically. There are various algorithms derived from other compressors in our catalog. The compressors are the same but transformed into OTT compressors, thus including expansion capabilities. In this example, we're expanding low frequencies. If you're interested only in compression, you can switch the range to tight mode, which completely disables expansion. Once again, the signal is compressed and the depth control works as a global dry-wet. You can select tight mode to entirely disable expansion. You can also adjust crossover points. Additionally, for a more classic OTT behavior, the envelope follower is also crucial. Inferno mod mode uses peak detection, while the others tend to use modes closer to RMS. Semi-Inferno and smooth modes feature even slower integrators, slower than RMS. If you want to freeze auto gain, since the incoming signal continues to change, there is auto hold mode. You can save the plugin in this state. Auto hold simply means that now, even if the input signal's volume changes, it maintains the same calculated output settings. Auto gain mode can also be disabled. In this scenario, the output knobs let you manually adjust individual bands. This behavior resembles classic OTT processors, which lack auto gain functionality. The central knob position is interesting in auto mode. as the plugin maintains balance without further corrective actions. For example, if you want to consistently boost low frequencies beyond the automatic calculation, simply adjust the output knob. This means the signal is balanced by the plugin, but you prefer it slightly imbalanced, boosting lows. This approach is useful when operating the plugin in mid-side mode. In this scenario, we're processing more of the side signal. These controls specifically adjust the side component. Here, we're boosting the side for low and high frequencies. Oak OTT has identical functionality to OTT Live. It features higher latency, but in general, it's the same product. It does, however, include additional features that significantly enhance audio quality. Indeed, there's oversampling, just like Oak OTT Live. But its various modes are based on linear phase FIR filters. There's also a control that allows selecting crossover filters as minimum phase, like Oak OTT Live, or linear phase, for the highest possible quality. You can even set intermediate positions, thus creating mixed phase crossovers. This largely depends on your musical taste. As a simple rule, if you want the absolute best audio quality, linear phase oversampling is the ideal choice. Aside from this, the plugin has the exact same functionality as Oak OTT Live. The complete Oak plugin combines OTT functionality with stereo manipulation features. Let's start with stereo manipulation. There's a global setting that can be individually adjusted for each band. In this case, we're adjusting the effect across all bands except for the first one, drift, which must be enabled individually. This is because drift is very audible and pronounced. It could cause noticeable pitch artifacts on finished tracks, though it works very effectively on the sub-region. All other controls behave exactly as you'd expect in a multi-band configuration. Here, the signal was mostly mono, so unless you apply a bit of drift, the stereo effect isn't noticeable. Regarding the dynamic processing, this section is highlighted in white. Unlike the stereo manipulation section, which is highlighted in red. The two sections are entirely independent, with stereo processing taking place before the dynamic processing. You can achieve a very modern sound, for example, by enabling drift in the subfrequencies. Gently widening the stereo field in the high frequencies, and then applying some compression. Here, the effect is exaggerated for demonstration, and you can push it even further or select more subtle compressors, adjusting the amount of compression accordingly. There's a slight increase in volume, not caused by the dynamic section, which is perfectly balanced, but rather because the stereo processing intentionally isn't included in the auto gain algorithm. This was an intentional design choice, clearly dividing the plugin into two separate areas, stereo processing and dynamic control, to accurately replicate our previous plugins.